Okay, so first thing we're going to do is start with vocabulary. So the real number system, that's made up of rational and irrational numbers. So it's made up of rational and irrational numbers. You may be thinking, what are rational and irrational numbers? Okay, so that we're going to get into rational next. So rational numbers, when you think rational, think fractional, okay? So rational, fractional. So any number that could be made into a fraction, essentially. So rational, fractional, okay? So again, when I say that, any number that can be written as a fraction. So we're going to give examples in a minute. Excuse my terrible handwriting, by the way. So this includes natural numbers, and those are numbers, numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on and so forth. So include natural numbers. It includes whole numbers. Remember, you guys did this last year. Whole numbers are natural numbers, but you just add 0, okay? Integers adds negative numbers. So like -4, -1,000. It also includes terminating decimals. So terminating and repeating decimals. Okay. So what the examples that I'm going to give are like the number 4. That's a natural number. The number 0 is a whole number. -7 is an integer. 1/2 is a rational number because it's fractional, right? Also, negative fractions are rational. But then we talked about terminating decimals. Terminating decimals are decimals that end, like 1.75. It has an ending place. Repeating decimals are those ones that go on and on forever, like 1.3, not go on forever, but they repeat the same thing over and over again, like 1.33333333, or 2/3 as a decimal is 0.66666. Irrational numbers are kind of the opposite. They're numbers that can't be written as fractions. So they can never be written as fractions. So they're numbers that can't be written as fractions, and they're also decimals that do not repeat or terminate. So try to think of a number that never ends and never repeats itself. Okay. Hopefully that number that you thought of is pi, right? Think about pi. It's 3.141519, and it goes on and on and on and on and on and on forever. It never ends and it never repeats itself. So that's a more obvious irrational number. But another irrational decimal could simply be 0.123445 ... We don't really know what comes after, but we know it never ends, so it never terminates. And since it hasn't repeated yet, we would assume it hasn't repeated. Okay. The next one would be a square root. So we're going to get into square roots, but simply know when you plug in a square root into the calculator, if it gives you a whole number, so say something like the square root of 9, which simplifies to 3. So if you put the square root of 9 in a calculator and it gives you a whole number, then it's rational. If you put it in the calculator, something like the square root of 2, that gives you a decimal, which means that it's irrational. So something like the square root of 2 or 3 times the square root of 5, things like that. Again, when you put the square root of 5 into a calculator, it'll give you a decimal. Okay, so there are some basic definitions. So now let's start classifying these. So I'm just looking at these. First one, A, 75.255443, ... So that's a decimal. So the things we would have to figure out, does it end? Well, that ... tells me it doesn't end. And it doesn't look like it really repeats itself. Okay, like yes, it has 2 5s, and yes, it then has 3 4s, but it's not like 0.333333, right? So this is actually an irrational number. Okay, so when I plug in the square root of 121 into my calculator, what do you get? Okay, so take a moment to do that. Plug the square root of 121 into your calculator. Hopefully you get 11. 11 is a whole number or a natural number, which means that it's rational. Now for C, I see a fraction. When I think fractions, I think rational, okay? Rational numbers are fractional. So I know that this is rational. Now this last one is 14 times pi. Plug that in the calculator. Think about what kind of decimal that gives you. But also think about pi is irrational. So anything times an irrational number is always going to give us an irrational number. Okay? So the next thing that we're going to talk about is comparing real numbers. And it's easier to compare real numbers. When they are in decimal form. So it's easier to compare real numbers when each number is in decimal form. Okay, so these next couple examples are really going to be you doing most of the work. Okay, so this first example, which of these numbers lies between 6 and 6.5 on a number line? Okay, so again, everything's better in decimal form. So we're going to make all of these decimals. So take a moment and plug those into your calculator and pause the video. Then I'm going to start. Okay, so once I have these all in decimal form, I'm just going to, well, you can clearly see which one lies between 6 and 6.5 because it's this one. But I would also just put these on the grid here. So this is square root of 35. This is the square root of 41. This one is the square root of 45. And this is the square root of 50. So the answer is B, right? Once you got your decimal, then I would also put them on the number line. Looking at the next example, we want to determine which of the following statements is true. what's going to be helpful for this? Because this is like the square root of 14 is in between which two values? So, but they're decimal values. So it's always helpful to convert everything to a decimal. So convert to decimal. That's going to be very helpful on the next page, which you're going to try by yourself. Okay, so convert this to a decimal. So the square root of 14, plug that in your calculator. When I did that, I got 3.74. So which one of these says the square root of 14 is between 3.7 and something else? So it's not A, it's not B. Okay, C has 3.7. But this is saying it's less than 3.7. So it's not that one. So it's got to be D. Okay, so let's look at the next page. Okay, so at this point, I want you to do these next three problems. So 1, 2, and 3 all by yourself. Okay, so pause the video and work on those. When you unpause, it'll have all the answers up. But it won't have any of the work up. So you need to be able to determine the work. And when I check your notes, you have to have the work there. So you can't just circle the answers. All right, so hopefully you got all the same answers as me. If you did not, this would be the time to raise your hand, ask me questions when you come back to class, or even ask some of the friends in your class, because sometimes they get things, before we do. So let's look at the next example. This one's really tricky. So I want you to spend a couple minutes trying to figure it out. So it says, which of the following inequalities is true for all real values of x? All real values of x, okay? So that includes negative numbers. That includes positive numbers. That includes fractions and decimals. One thing that I'm going to tell you that will be helpful is to simplify these expressions if possible, aka the last two would be really helpful if you simplify them before you start plugging in values, okay? So I would maybe make a little table and try negative numbers, positive numbers, fractions, and decimals into each one of these. Okay, so pause the video and try that. When you unpause, I'll just have examples of what doesn't work for each one and the answer. So as you can see, for A, it doesn't work for fractions. For B, it doesn't work for regular numbers over like 2. C is the only one that works because 4x squared is always going to be bigger than 3x squared, no matter what you plug in. D, again, any number bigger than 2 will make it not true. Okay, so now below this is your homework. That isn't due until Wednesday. So it's just answering a couple of questions, okay, and I'll check that. Make sure you show your work, all right?